Pure Storage Capacity Optimized All-Flash Storage session. My name is Eric Kruger, and I'm the vendor manager for Pure Storage here at Westcon. Before we get started, some housekeeping. If you have any questions during the session, please use the Q&A field and we'll address them at the end. Also, please be sure to complete the survey questions which will appear at the end of our session. There is a $15 Domino's voucher up for grabs. I'm honored to have a Pure Storage legend join us today. He's been with Pure from the very beginning, employee number 6, and the first non-engineering hire. He's the man responsible for picking the color orange and for launching the company publicly. Joining us live from the United States, Mr. Matt Kixmoeller. Over to you, Matt.
In this very difficult time where I'm sure you have many things pressing. I would love to be able to fly down and visit you guys at your beautiful island, but that unfortunately won't be happening for a little while. But I'm always looking for an excuse to come down and see New Zealand. Today we're going to be going over a new offering from Pure Storage and a new category around bringing flash to the capacity optimized storage segment. But before we dive in, we thought we'd just include one slide if you can allow us to give a quick overview of Pure Storage for those of you who may not know us. Pure just entered our 10th year, and when we launched the company, we launched with a very simple idea to basically democratize flash storage, building the first all-flash array and bringing flash to all workloads in the data center. And so I feel like what we're talking about today is really bringing that initial mission even further forward, where we're bringing flash to the next generation and next set of cost-optimized workloads in the data center. Pure overall is nearing $2 billion in revenue, over 7,000 customers globally. But the statistic about our business that I'm most proud of is our industry's best Net Promoter Score. I view that as not only a measure of customer satisfaction, but the reliability that our platforms brings to our customers. And so that's a key thing that we measure the entire company on at Pure. So if in the first generation or the first decade of Pure, we focused a lot on designing and delivering the first all-flash array, when we think about the next decade, we're really helping our customers implement the cloud model for storage as a service in their environment. That means having storage that's simple and automated so you can deliver storage on demand to your customers internally. But one of the key things when you think about that as a service cloud model for storage is multiple service levels. If you go to the public cloud, there's not just one performance level of storage. You have different tiers of storage at different price points and different performance points. And so a lot of what we've done in our first decade is made it cost effective to really consolidate tier 1 storage on flash. What we're really now focusing on is bringing a next generation of QLC optimized flash arrays to market that help bring a lower tier of storage, but still deliver all the efficiency of all flash. Part of our goal at Pure and our mission from day one was to deliver the all-flash data center. And when we used to talk about the all-flash data center 10 years ago, to be honest, people thought we were a little bit crazy. But now I think as you have seen flash really come in and change your tier 1 applications, leveraging flash for multiple workloads is starting to make a whole lot more sense. I tend to think about the data center and all the workloads in a little bit of a triangle or a pyramid like this, where you can divide it between structured and unstructured data, block or file and object data, and also in terms of performance and cost. So at the top, as I said before, we typically see the tier 1 databases, the key virtual machines, and we've been serving those with our FlashArray//X product for many, many years. That's focused on the highest performance, and we can now deliver as low as 100 microsecond latency with NVMe over Fabric and storage class memory. We introduced FlashBlade 4+ years ago to deliver scale-out file and object to go after real-time analytics, AI, and high-performance computing type workloads. And we've actually even seen a lot of adoption, believe it or not, of that product in backup and restore use cases, because being able to do a massive restore of your environment as fast as you can is a key part of a DR plan, especially these days as it results to recovering from a ransomware attack. But today we're going to be talking more about the capacity optimized tier, how you can go after the next generation of your environment. And I'd ask you very simply, just think about where you still have disk in your data center. where's their disk where you could still use higher levels of performance and simplicity? That's what FlashArray//C is all about. So let's dive in and talk a little bit of technology. So one of the unique things we do at Pure is we've really worked hard to optimize the entire stack within our array, from software to hardware, for flash. And if you look at a lot of the all-flash arrays on the market today, there's a dirty little secret in that they still have a lot of disk remnants inside their architecture. You see things like disk protocols, SCSI, SAS. The first S in SAS is serial attached SCSI. And so given the massive parallel performance opportunity of flash, having a serial connection to all that flash is a real challenge. You see disk interfaces like SATA, but most problematically, when you dive into an SSD itself, you see a controller that acts like its own little file system and its own little almost storage array within inside each SSD. And let's think about what an SSD is, a solid-state disk. It's basically taking a lot of flash and then doing a lot of work to pretend like it's a hard drive. And so at Pure, long ago, we asked ourselves, why are we still pretending that flash is a hard drive? Let's just get beyond that. And so in our products over the past 5 years, we've introduced a new architecture called DirectFlash. And quite simply, this is the ability to take raw NAND chips and connect them directly to our software. We do that with the blades inside FlashBlade that you see at the right here, and inside the DirectFlash modules on the left that we build inside FlashArray. As I said before, if you look at a traditional storage system design, you have individual SSDs. There could be 10, there could be hundreds of them, and each one is acting independently. Each one has extra flash inside for over-provisioning, which is inefficient. And so what we've done is we've designed this kind of flash module that we call DirectFlash, where it does a very simple thing. It just connects a large pool of flash to our system over fast NVMe links. And then all of the software intelligence that used to live inside an SSD for managing flash, we brought up to the global software layer within our Purity operating environment. All the I/O scheduling, all the wear leveling, everything we do now happens in software, so we can do it far more efficiently across the entire system. The results of this architecture have been amazing. We've been shipping it in the field now for over 3 years. And so not only is it simpler, it fails less. We've seen about half the failure rate of our DirectFlash modules compared to traditional SSDs. It delivers much lower latency and much more consistent performance. And it's more efficient. We make the best use of flash, which helps us drive down the price. And that's exactly what we're trying to do today with our capacity optimized offering. So it's an exciting time in the flash market because we see new forms of solid state memory coming on the market. At the high end, we have storage class memory, which we now easily support slotting into our FlashArray X series. And at the low end, we have new QLC flash. QLC is a flash technology that fits 4 bits of information per cell, or quad level cell. The nice thing about it is it's lower price. The challenge, though, is it's less reliable, it wears out faster, and it's lower performance. And so these are all things that we need to manage via our software. But Pure is in a great position to lead in QLC because we can talk to the flash directly. And we've gotten very good at learning how to program to flash like this and to make it enterprise class reliable. It's enterprise class reliable to the extent that we offer the exact same warranty protection and wear level protection as we do across all other flash we sell. And so from a customer perspective, there's no risk in using these new tiers of flash. So the product that we've built around this architecture is called FlashArray//C. And the C stands for Capacity Optimized All-Flash Array. Our real goal here was to deliver a product that doesn't just go after the same applications that you've been able to use a Tier 1 flash array for, but really helps you go after your Tier 2 applications. Departmental applications, Tier 2 VMs, large-scale file environments, etc. It delivers the same predictability in terms of flash performance, and although it's lower performance than FlashArray X, it's still a heck of a lot faster than the disk it replaces. And in terms of a price advantage, you can think about this overall as about 40% less expensive than a traditional flash array. And so this really helps you go after a new tier of use cases that couldn't afford to be on flash before. Now, one of the best things, though, about this product is it's just another flash array. So for customers that have basically gotten used to our Flash Array X and the simplicity that it delivers and all the enterprise services, all these come straight away to the Flash Array C. So Flash Array C, although it is lower cost, I also want to mention that it has the capability of becoming quite large. And so, we sell versions of this that range from 366 terabytes raw, which is over a petabyte effective, up to 1.4 petabytes raw, which is over 5 petabyte effective. And that's just the first version. So stay tuned as we launch more versions of this over time. We've done something unique in the New Zealand market, where often we understand that customers want to start a little smaller. And so we're offering, specific to this market, an even smaller device that starts at 183 terabytes raw, which is over half a petabyte effective. And it can grow non-disruptively by just activating the flash that's actually in the other side of the array if you want to license it over time. So one of the great things about Flash Array C is it's really designed to work in concert with Flash Array X. And so, for example, you can obviously deploy multiple tiers of service within your environment, where your tier 1 applications are on Flash Array X, your tier 2 applications are on Flash Array C or test dev. But because we have the same exact snapshot and replication and copy software that link these products, you can easily connect them together for data workflows, like having production on tier 1 and test dev on tier 2, or doing disaster recovery between an X in your primary data center and a Flash Array C in your DR site. We also have an offering called Cloud Block Store, which takes the same Purity operating environment software that runs on our Flash Array and allows it to run natively in the Amazon or Azure cloud. And so those same workflows can also transparently move to the cloud with the exact same APIs to run on-prem or in the cloud. So let's talk a little bit more about some of the use cases that we see customers leveraging Flash Array C for. One of the easiest, I think, is to really just bring it into your VMware environment. VMware has lots of tools with vMotion and Storage vMotion to easily move workloads between data stores. And so you can have a tier 1 Flash Array X, you can bring in a Flash Array C, and you can use the VMware tools to move VMs to the right tier depending on the certain conditions. And of course, as performance may change, you have the flexibility to move VMs between these tiers. This allows you really to establish 2 different service tiers and to make sure the Flash Array X is working on the most important applications in your environment. The second thing Flash Array C can do is it can bring DR to a new class of applications. And so now you can make it more affordable to use replication to a DR site and have that land on a Flash Array C. We see a lot of customers taking advantage of this for test dev. Imagine having your primary SAP database running on Flash Array X, taking snapshots every half an hour, refreshing those as you like to Flash Array C so that the test dev team can be using the most current data coming out of production. And then finally, we often see data protection type workflows where customers want to create an air gap against ransomware. So they want to take snapshots from Flash Array X and then move them over to Flash Array C for retention. So you can imagine, for example, a retention strategy where you might take snapshots every half hour or so on Flash Array X, so you have that fast recovery in case you need it. But then you're replicating those snapshots to a Flash Array C, and you're maybe retaining there for a week. So you have many, many recovery copies in case you have to go back further in time, and you have an air gap solution because they're on different systems. So these are just a few of the use cases that potentially can be taken advantage of with Flash Array C in your environment. So the final thing I just wanted to summarize with is that really Flash Array X, Flash Array C, and Cloud Block Store represent a single product family and a single software line within our company. And so that means they work exactly the same, They have the same exact APIs and interfaces. You can automate them in your environment exactly the same. And so it makes it very, very simple to establish a tier 1 and a tier 2 all-flash environment at very different economics that make it cost-effective for every application in your data center to take advantage of flash. And so with that, why don't we turn things over to Stu? Stu's got a couple of comments about specific customers in the region who are taking advantage of technology, and then we'll end by opening it up for questions.
Thanks, Kix. So really, a couple of quick things to consider from a local perspective. And the first point is, we know customers do nothing more than talking to their peers. And we'd encourage you, if you have a peer in the industry that is a current Pure customer, please reach out and talk to them. Don't just take our word for it. We've been in New Zealand essentially for 6 years as of tomorrow. And over that time, we've brought on a whole host of customers across a whole host of verticals that are enjoying the benefits of the evergreen storage model and the Net Promoter Score that Kix mentioned earlier. So please don't take our word for it. Have a chat to the customers, and we've got some customers with public case studies that you can grab off of our website. The second thing I'd like to leave you with is, this traditional approach of infrastructure refresh by wheeling in a forklift has become a thing of the past. We've got a number of customers now globally and in New Zealand that are on their second or even third generation of Pure Flash arrays without rebuying any capacity, without having to do any data migration, without taking any downtime, and are lowering their total cost of ownership over time by investing in Pure. We know that there's a significant amount of change happening in the storage industry with other vendors at the moment, most of which are requiring forklift upgrades. Your move to Pure could be your last forklift upgrade. The last thing I'll leave you with, and if you could flick to the last slide, Kix, is we've got a few events coming up that we'd like to offer attendance to. We've been running some technical boot camps over the last 6 months. These have been in-class events traditionally, but with the COVID situation, we've been delivering these virtually very successfully, a small classroom style technical event where you can actually get hands-on, participate in some labs, and get a feel for what the difference Pure can bring to your business. We've also been running a virtual coffee series, the next one of which is coming up on the 28th of May, where we'll be talking around containers and analytics. So look out for some invitations coming on that. And we've also developed a more deep dive technical bootcamp around DevOps and automation. So if you have some interest in any of these events, please let us know. We'd love to have you come and join us. The last thing that we do have coming up is our annual Accelerate conference. And again, in the post-COVID world or the current COVID situation that we're working in, this again will be a digital event. Very much along the similar theme to this great event that Westcon have deployed with Imagine this year. We'll be bringing Accelerate as a digital event this year. So I strongly encourage you to register using the link provided here. The last thing before we flick across to Q&A is to reiterate the reminder that Eric provided at the start of the session. You will be receiving a survey at the end of this call today. We'd encourage you to respond. We'd love to get your feedback. And as a thank you for that, we'll be providing you with a $15 Domino's voucher for you to enjoy now that we're moved into level 2. So with that, we'll cross over to Q&A. So if anyone does have any questions that they'd like, we've got a minute or two left. Please use the Q&A function. I can see there's a question that jumped straight out at me, Kix, that I'll pose for you to answer. And this is from Brendan. Can we mix and match X and C into a single chassis?
So X and C do use the same physical chassis, but when we brought C to market, we really wanted to do all we could to completely optimize it for QLC architecture. And so it doesn't just have a lower tier of flash. There are many changes to the software, many things up and down the stack that really optimize it for efficiency. And so today, they're independent arrays. You can certainly interconnect them and move volumes between them as we discussed, but they need to be deployed independently.
Fantastic. Don't see any further questions coming up at this stage. So look, if you do have any follow-up questions that you'd like, please reach out to the local team. We'd be more than willing to engage and support anything that you need from us. Other than that, well, thank you very much for your participation and attendance in today's session. And we look forward to seeing you hopefully face-to-face in the very near future.